Hi, everyone. Thanks for joining today's webinar on predicting material properties utilizing machine learning. We'll get started shortly. We're just going to wait about 3 more minutes for others to join, and then we'll get started with today. And again, appreciate you guys joining, and hopefully you'll learn something useful. Hi, everyone. I think we'll get started now, 3 minutes past the mark. Before we get into how you could predict material properties using machine learning, I just wanted to quickly introduce myself and my colleague Nicola, who's going to be helping me demo the tool later on in the presentation. So I'll just give myself a quick introduction. My name is Natalia, and I'm the territory manager for North America. So if you're already a Total Materia user, if you need anything, um, you could always connect with myself or my colleague Nicola. If you're learning or here to learn more about what we do and the different topics we cover, again, always feel free to message us after webinars like this. Before Nicola gives himself an introduction, I just wanted to quickly go over how this webinar will be set up. So we're going to go over a couple of slides, just introduce you to our tool and how we help our current customers with predicting material properties. And then Nicola is going to show you how to do so with specific use cases within the demo later on. And if you have any questions during the demonstration, feel free to add in the chat box, and Nicola and I will get to them as soon as possible. Nicola, do you want to give yourself a quick introduction and then we'll get started?
Sure, thank you, Nats. Hi, everyone. My name is Nicola. I'm the account manager here at Toll Materia. Thank you for joining today's webinar on Predictor, a solution we created to help you, fill in the gaps, the missing gaps of material properties. We'll show you both how to predict mechanical and physical properties, as well as stress, strain, and fatigue, how to perform temperature dependent predictions, as well as how to predict directly from chemical composition. So just sit back, enjoy, and feel free to ask any questions in the chat box that you might have, and we'll definitely get back to them.
Perfect. Thank you, Nicola.
Sure.
So the first thing that always comes to mind is what are the different problems we could solve by giving you a tool that helps you predict material properties? Of course, from a problems perspective, if you're a materials engineer or a simulations engineer, your goal is to have validated materials information at all times for specific use cases. But unfortunately, some of those properties may not exist through standards, producer data sheets, even in your internal test banks. So what do you do, or why don't you have the properties you need at that point, and what could you do later on? As I mentioned, sometimes that information is not published by the material producer or the standard. Sometimes suppliers notify you in a change in chemical composition, and you want to understand the behavior of that material and how different properties change based on that application. Especially now with a lot of materials that are going towards a greener solution, you're going to see definite changes in the chemical composition of some, metals, polymers, and we'll try to help you navigate through that without having to wait for a different material test and spending money on that. Sometimes the information that you're trying to look for might be for a very specific scenario that might not yet exist, but also maybe costs a lot to test. And as I mentioned in my previous 2 points, it all comes down to material testing. And it's not that it just takes sometimes a while for all of that to get sorted. It's also that it could cost you thousands of dollars. So that's why we've created a solution called Predictor to help you predict those material properties. And what our solution does, it understands the material designation or the chemical composition, meaning that you could add in a 7075, 6061, 2024, you name it. So you could, let's say, predict certain material groups and materials, but you could also insert your own chemical composition with that. It, of course, is a lot less costly to have a license to Predictor than to material test. And on the other side of the coin, you're really going to be able to perform several calculations per day rather than waiting for weeks for those results. And most importantly, our models are constantly being enhanced and is getting learned by new experience and new data sets. And I'll go into more detail on how we collect those data sets and how all of that works. But first, we're going to go over the four main pillars of the Total Materia platform. Most of you know us as our materials reference library Horizon. So that's where you could find material properties on over 550,000 material designations coming from metals, polymers, composites, fiber, ceramics, wood. So you name it on the different types of material groups that we cover. But we also cover different properties like basic mechanical and physical properties, corrosion data, welding information. So there's really a lot of different topics that we cover with Horizon. Later on, we could show you how you could access for a free trial through that platform. But just wanted to quickly mention that because it's an important part to our materials prediction tool as well. If you have your own data that you want to organize and connect that information across the organization, like to CAD, CAE, PLM, Integrator is your best bet. So that's where you could import your own internal material information and share that data across the organization. We also have a tool that helps you assess materials compliance and sustainability, helping you make greener material choices, but also making sure that the materials you're choosing are compliant at the very start of your material decision-making process rather than later on. And finally, Predictor, where you could predict material properties and filling in those gaps of unknown information. And those are four pillars to the Total Materia platform. We're going to be definitely focusing on Predictor for the remainder of today. But in general, the different departments and people we try to help with Total Materia is not just the standard materials engineer or compliance and sustainability engineer. It's really from a quality perspective, supply chain, purchasing, and sales. So making sure that the right people are seeing the right information and being able to find equivalent materials fast due to other causing issues. And also from a simulation perspective that everyone has the reliable material information. And that's why we have those four pillars at Total Materia. So material reference data, a way of organizing your own internal data, compliance and sustainability, as well as material properties prediction. to cover all departments and people throughout an organization from a materials perspective. So now for the main reason why we're all here today is how can we predict material properties utilizing Predictor, but also how did we set up Predictor to be able to do that as well. Well, of course, one thing that Predictor could do is predict material properties. So you could add in your own inputs like heat treatment, form, chemical composition, as I mentioned. So you don't have to utilize the chemical composition data from total materia. You could add in your own properties prediction. We're also able to predict polymers. Of course, we don't have always the chemical composition data for polymers, but I'll show you how all of that works soon. We have different confidence indicators to show you how the predictive values measure against the model. And then also, once you predict all these values, it's very valuable for you to be able to share that data. And all of that is possible with Horizon. So Horizon, remember our materials reference library, so that little blue logo at the left to total materia here. Without reliable materials information that we've been collecting for over 25 years, we would not be able to create machine learning algorithms for Predictor. So it's a really great tool to have for you to be able to predict basic mechanical physical properties, but as well as stress strain curves and fatigue data for metallic materials. As I mentioned, we cover metals and polymers for now in Predictor. We're always looking to add in more material groups, but we need more data for that. But just as a quick recap, we have over 160 machine learning models that will help you predict properties for over 300,000 materials. So we have different models because each material group and then each property behaves differently, and there's different inputs to that. So that's why we have all those different models. You're able to predict over 20 properties, so a mix of mechanical and physical properties, stress strain curves, and fatigue data points. You could compare those predicted properties and behaviors either by switching over the chemical composition data. You could also compare data from Horizon to Predictor in case you want to see, okay, if I adjust this heat treatment or the thickness of this material, how is it going to change to what is already available out there? And as I mentioned, which is most important, we have pretty good ways of allowing you to share those reports internally and externally. A lot of you probably have the same question as how do we create and execute these models? And first we start off with Horizon. So that's where we collect all that information for specific materials, and we first classify these materials and then do the proper data validation steps. So we have an AI team of about 6 to, I think now actually 7 engineers that are collecting that information from Horizon. And by the way, in the Horizon team, we have another 20 engineers inputting the data on a daily level, but we do monthly updates to the database. So they classify the material, do the proper validation steps, and then create those different models. And really, it's super easy to use Predictor, and Nicola's going to show you how to do that. You either choose your designation or composition, you select your model, you define your different parameters. So you could add in heat treatments, form, temperature, also define which property you want to predict. And then also at the end, you have your list of results with different confidence parameters. So then you could see how well the model behaved and how close the predicted value is to the model as well. We have 2 material groups that we're working with here. And how do we classify them? For metallic materials, it's very simple. We classify the data, or the materials rather, by utilizing chemical composition. So this is a screenshot from Predictor. You could either use our designations, or you could, which has a chemical composition attached to it. You could edit that composition, or you could import your own. So for metallic materials, it's quite simple. For non-metallics, since we usually don't have the whole chemical composition, usually producer data sheets don't like giving that information out, as most of you know. We classify these materials as generic material groups, And then you could identify these materials based on fillers, densities, UV stabilizers. So you first select that material. So this is an example of Macrolon 1095. And then you'll see at the bottom here, once I select that material, you have a filler content, a density, and then if there's any other attributes, we add that information in. So then we could specify the material even further. It's just not specified by the chemical composition, but rather the material group. And some of the key benefits for being able to adjust these chemical composition inputs are, as you imagine, on a cost reduction perspective, optimizing your material selection process. This has helped our customers select better suitable materials for a specific application by doing these tweaks. And of course, besides that, avoiding failures, repairs, replacements could go a long way. And also from a supply chain efficiency perspective, maybe you don't need to use so many different types of materials. You could come to a common ground with some materials based on that chemical composition input, and having that data validated that you're able to create or choose different materials based on your design parameters. Of course, understanding how the material behaves under extreme conditions could prevent you from structural failures and risk mitigation. And then from a design optimization and new material development perspective, uh, tailoring these materials for specific applications helps you with prototyping, but also understanding from an optimization standpoint, from a design optimization standpoint, how this material could behave, and having the capability of adjusting these chemical composition inputs in Predictor rather than having to do additional research and also material tests could just give you information faster, and then you could go from there. Quickly to go over the different mechanical properties, physical properties, stress strain curves, and the fatigue data that we cover. We cover them, you'll see they're bundled up in material groups. So the mechanical properties we cover are usually UTS, so tensile strength, yield strength, and hardness. And of course, as you could see as I'm going through the list, some materials have more properties, some have less. So it's again depending on the data that we have in Horizon. So for polymers, we cover 5 properties. Stainless steel, you could see we cover 4, but we try to classify them at all times. If there's a specific material group that you need or that you're working with and that we don't have in our list, please let us know. We would love to take that back as feedback to our technical team. But in all, you're going to find mechanical and physical properties covered by aluminums, coppers, titanium, superalloys, stainless steels, structural and constructional steels, magnesium alloys, iron, and polymers, as well as the physical properties. So we got a really good set of all of that material information. And the types of physical properties you'll see: modulus of elasticity, thermal expansion, thermal conductivity, electrical resistivity for some materials, density, and heat capacity data as well. And again, all this data is taken from Horizon. And finally, our nonlinear properties. Unfortunately, we only cover that for metals. And some material groups cover both fatigue strength data and stress strain curves, but some only cover fatigue strength. So now Nicolo is going to take you through the platform and go over a couple of different use cases. If during the webinar that Nicolo is just going to continue on with, if you need us to answer any questions, feel free and put them please in the questions box. But Nicolo, can you please take it away with the demo now?
Absolutely, Matt. Thank you so much for providing me with an overview of what Predictor represents. I'll just go ahead and share my screen now and walk you guys through the platform itself, show you how it all works, and show you all everything in action. Can you just confirm that you see it, the
Yes.
screen? You do?
Yeah, yeah.
Okay, perfect, perfect. So yeah, if we go to our main platform, Horizon, and let's say you would like to search for one of, let's say, aluminum alloys. Let's just use this one as an example. And when you click inside the material, you see that there are no mechanical properties, no physical properties except for density, as well as no stress strain diagrams, no fatigue. And even if you go to the cross-reference table to find something here and you try to compare or see if there are any mechanical or physical properties, you don't find any, what you can do is you can just go straight to a predictor and just search for that same material designation. So here you can go ahead and search either by composition or on a material basis. And let me just clear this one from before. Let me just search for the same material, click on search here, and you'll be able to select the reference. In this case, we have only one, but usually there are more references you can choose from them. You'll see that later on. You can also edit the chemical composition and select, the material you would like to go with. And let's just go with the first one coming from the AAUS standard. Click on next step, and then you can also, select different properties you would like to see predictions for. You can also choose different output types, performance ratings, and applicability. And now we can go ahead and select one of the properties here. Let's go with the tensile strength. And we can choose the model 1147, which predicts the approximate value of the ultimate tensile strength at different temperatures strain on materials having tensile strength from 16 to 893 megapascals. So let's just choose that one. Click on next step. And then here you can define all the required inputs. So let's select plates as products, for example. Here you can just select the dimension type. The dimension, let's go with 20. You can select different heat treatments. Let's go with T6, as well as different minimum maximum temperature values. So let's go with minus 100 to 400, for example. And then here, let's keep 50 steps. And then just click on predict. And here we will get the model's prediction, as well as the performance stats below. Here, you'll be able to see, the temperatures, all the values, and as we can see here, it's fully applicable, meaning that all input values were in the testing domain. And if you would like to include a confidence interval as well, so you can see that as well, you can definitely do that. You'll also be able to export this to Excel. You can add this to the report builders. You can PDF it, share with your colleagues, justify the decision you're making. You can definitely do that as well as save this prediction if you would like, to give it a name, give it a description. You certainly have the ability to do that right here. And then after we did this, if you would like to, let's say, add this to the diagram comparison, you can definitely do that right here. So just click add to diagram comparison, and then you can go ahead and go back and change one of the inputs if you would like to compare, different scenarios. So if we go back, let's say to step 3 and change the product from plates to, let's say, bars, or change this from thickness to diameter and dimension from 20 to 10, for example. You can just click on predict, and here you have the new model's prediction, which you can again add to the diagram comparison so you can see how they compare. And then from here, just go to diagram comparison, which is all within Material Console add-on within Horizon. And then here you'll be able to see how they compare and both curves below with different values. So this would be the difference between the two. And then something else, if you remember, there were also no stress strain curves for this particular material. So if we go back to Predictor and search for the same material, select the same one, click on next step, and here instead of tensile strength, let's just select stress. Let's include that one, and here we can select this model engineering stress strain curve at different temperatures, click on next step, and here we can define the required input. So let's again go with plates. Let's go with dimension type thickness. Let's put the dimension, let's do 20. Direction, let's do long. Heat treatment, we can select T6. The test temperature, we can do 20, and maximum strain, 0.2, for example. And then click on predict. And here we have the model's prediction. Again, the performance stats, you can learn more about them right here if you would like, to see how they compare. And here you can find the model's prediction. And then if you would like to do, something else, such as fatigue, for the same, if you remember, there was also no fatigue for this specific model. You can just go back again to step one, select the same model, click on next step. And then instead of stress, filter by fatigue. And then here we can select, for example, this model, which predicts the approximate actual fatigue strength at the room temperature. And it was trained on materials having fatigue strength from 14 to 427 megapascals. So let's just select that one. Click on next step. And then here you can add your parameters and inputs. So let's go with heat treatment. Let's select T6 again. You can select number of cycles. Let's go with the first one. Here we can select this one, for example, and specimen. We can select smooth. Click on predict. And here are the results. And now something else that I also wanted to show you guys, since I did mention that you can both predict from a material basis as well as the chemical composition. So if we go back to step one, and let me actually just go to Material Console to show you where you can view these diagrams. So if you go to Comparison View within Material Console, just go to Diagrams, and here you can find them. And let me just go ahead and delete this so it doesn't create any confusion for the diagrams that I'll add later. So clear all, and then if you would like to also predict from chemical composition, you can definitely do that right here. And just before I do that, let me just search for this material also coming from the AA standard. Click on search, and here you can, as I mentioned, both edit the chemical composition and select different references. So for this one, let's just select the one from 2017 and select the material here. Click on next step. And here you can just filter by one of the properties. Let's just select tensile strength, for example. We can select again the model ID 1147, predicts the approximate value of ultimate tensile strength at different temperatures. Click on next step. And here we can again add the inputs. So product, again, let's just go with plates for the example's sake. Let's select thickness. Dimension, we can choose 20. Heat treatment, let's do T3. Temperature, we can add 20 steps, and let's go with minus 200 to 400 for this example. And then just click on predict. And then, as I mentioned, you can add this to the diagram comparison. And as Nat mentioned earlier, you can change the chemical composition, refine one of the elements, the values, and then you can just go back to it and see how it would compare. So just click here, add to diagram comparison. And what we can do now is go back to step one. And here you can actually edit the chemical composition of one of the elements. So let's go ahead and change the value of copper from 5.5 to 0.5. Click on next step. Let's select tensile strength again, 1147. Let me just input the same things as earlier. Let's go 20, T3. Let's select 20 minus 200 to 400. Let's just go with the same example. So the only difference would be the value of copper. And then click on predict. And here you have the new one with the changed copper value. So you can add this one to the diagram comparison as well. And if you go here, you'll see the difference. And now something else that I wanted to show you guys is if you go back to Predictor and to step one and predict not from here, but if you would like to go from here, let me just clear everything. You can either import the chemical composition, or you can input the values manually based on what you wish for. Here you can let's just select the base element as aluminum. Let's just keep it that way. Let's add the value of copper to 0.05. We can add this one to 0.05. Then we can do this one 0.01, for example. Let's select this one as 0.4. Let's go with this one 0.25. This one 0.05, and then the last one we can do 0.03, for example. And then click on next step. We have some models here. We can again filter by tensile strength, for example, and we can select the model, the first one, which predicts the approximate value of tensile strength at different temperatures. Click on next step, and here you can add, let's just go with plates again, dimension type thickness, dimension 20. Let's use the same example, T6. Different here you can add also def 20 steps, and let's add 0 to 300, for example, and then just click on predict. And what you can do is, yeah, definitely add this to the diagram comparison. Just before I do that, let me just delete the old one so they, again, don't create any confusion before I add this one. So predictor, let's add this to the diagram comparison. And then if we would like to go back to step one and edit chemical composition, we can change, for example, the value of magnesium to, let's say, from 0.05, we can change it to a 2.5, for example. Click on next step, select the same thing, same parameters and inputs, and here we have the new prediction. Go to diagram comparison, and here you have it. So you can compare that within a matter of seconds and minutes instead of, as Ned mentioned before, waiting to hear back and see the results. So yeah, those are the main things I wanted to show you as far as chemical composition goes. And the last example that I also wanted to show you, since all of these materials were metallic materials, you'll definitely be also able to do predictions for polymers. So if we go back to a tool search here within Horizon, within our main platform, and we search, for example, for one of the polymers, let's just select this one, for example. Click here, and once you go inside this specific material, you'll find that there are not many properties available. So what you can do is just go again to Predictor, select the same material, click on search, and filter by, let me just select this. Okay, let me go ahead and find it. Yeah, we can just go with the first one. Click on next step. Here you can filter by yield strength, for example, and we can select the model AT1347, which predicts the approximate value of yield strength at room temperature trained on materials having yield strength from 7 to 260 megapascals. So let's just select that one. Click on next step, and here we can add the strain rate. Let's go with 5, and you can also add the modulus of elasticity. The Young's modulus here you can estimate using the AI model, or if you would like a more accurate prediction, you can just input your real value that you're actually looking for. So let's just select it then here, and then once you click on predict, here you have the model prediction and the model testing performance. And one last thing, I also just wanted to see if you guys would like, to test out Predictor. You certainly have the ability to do that for free. Let me just go ahead and share a quick poll just so you can vote and see if you would like to test Predictor out. If you can just, take a couple of seconds to vote so we have, a better idea. If you would like, to test it out, you can definitely give it, we can definitely give you access for free so you can explore it in more depth with your specific use cases and play around and see if it brings any value to your current workflow, if it helps with your projects, material information gaps. So yeah, if you can take just a couple of seconds to vote.
Great. While everyone's voting, I think that's it for us today. Nicola, thank you for showing Predictor to its full capabilities. And if anyone has any questions, we still have a couple more minutes to go over anything. So hopefully, I see there's no questions now. So hopefully, Nicola and I were able to explain how the tool works, how we were able to, well, not we, but Total Materia create the tool as well, and from what kind of data. Again, we'll connect with you regardless after the webinar. And if you need anything from our end, if you're already a Total Materia user, feel free to connect with us. But yes, we'll be here to support you guys. If there are no more
Absolutely.
questions, yeah, feel free to log off today's webinar. We're going to be sending out an email with the recording as well. So yeah, Nicola, did you want to add in anything?
No, that was basically it. Thank you, Matt. Thank you, Matt. And thank you so much, guys, for joining today's webinar. I hope it was informative and helpful. And yeah, as Nat mentioned, feel free to, send us any questions you guys might have if you would like to have a more, detailed, in-depth session on Predictor so we can go through, your specific use cases, or if you would like, just to test it out yourself and play around, explore in more depth, just let us know, and yeah, we'll definitely be more than happy to help you out, guys, with everything. So yeah, thank you again. It was great walking you through the whole thing, and thanking Nat for presenting everything and helping me.
Great. Thank you, everyone. Hope everyone has a great rest of their day, and we'll be in touch. Have a great one. Bye bye.
Have a good one. Take care. Bye bye.